Okay, real quick, now we're done. Two more problems. Problem 1524, use the oscilloscope reading in this diagram. Find the RMS value of the current in the series circuit. Very simple. um, it gives you the peak-to-peak reading. And if you remember, that peak-to-peak is the total sinusoidal swing. So you take that 8.27 divided by 2, that gives you the amplitude, and then you divide that, you multiply by 0.707, which is the same as dividing by the square root of 2. So that gives you 2.924 volts. Likewise, with the current, you just take the RMS voltage divided by, uh, it has an R2 here, I'm not sure why, but that's R is 10K. So 4.924 divided by 10K is 2.924 microamps, which is not right. I think that should be, oh no, it's 292.4 microamps, or it would have been 0.2924 milliamps. So that is right. And then part B is determine the capacitance in C. The way to do that is, what they're doing is they're taking that other formula, E squared, which is this E, equals V sub R squared plus V sub C squared. Those are all the magnitudes. E is equal to the square root of those two magnitudes from the capacitance diagram, or the voltage phasor diagram. So what you can do is square everything, and you get 12 volts squared equals 2.924 squared, because that's what we figured out here, and then V sub C squared. So then you multiply these out, and that is 144, 8.55 V squared. You subtract 8.55 from both sides, and you get V squared equals 135.35. Take the square root of both sides, and then you get this, which is 11.64. So then you take the value of the RMS over, this is Ohm's law again, but what you're looking for is to find the capacitance, so you have to find the reactance first. So you take that voltage, divide by the current, and you get the capacitive reactance, and then using this formula, you multiply both sides by C and divide by XC, and then you get this formula, which is just a derivation of this formula. They give you the frequency, you found the reactance, so when you multiply it all out, it equals 100 picofarads, or 0.1 nanofarads. And then problem 27, it says calculate the voltages V1 and V2. Those are the vectors for the circuit using the voltage divider. And basically what you do here is you take E, which is your phasor voltage, and you multiply it by whatever voltage you're looking for. This is at 40 ohms, and it's a plus 90 because it's an inductor. And then you take the total impedance, which is at 6.8 plus J40 plus 22, because that's another resistor. Combine the 6.8 and the 22 to 28.8 J40, and then you multiply these two to get a 2400 volt. Add these two to get 95 phase angle. And then what you have to do here is, and they didn't show it, you have to convert this to phasor polar form, and then you end up getting this answer. You guys know how to do that. You take the square root of 28.8 squared plus 40 squared, square root, and that'll give you this number. and then you take 40 divided by 28.8 and take the inverse tangent of that, and it'll give you this number. Same thing with V2. You're taking that resistance times that voltage divided by the total impedance, which they figured it out here. They put it in phasor form or polar form, and then you multiply this out. They got 1.2332K, and then 0 plus 5 equals 5. Then you take this 1.32K divided by 49.29, get 2678 volts with an angle of 5 minus 54.25, which is negative 49.25.